Solving equations in algebra is quite an important process. It's used in all of our sciences, um, just all of our engineering work, electronics, mechanics, dynamics. It's just used everywhere. And so we're going to look at and solve some basic types of equations. We are going to understand when there are many solutions and no solutions whatsoever. We're going to mention from time to time that you should always check your solutions to an equation, because if you do that, you'll know that you're correct each and every time, and we'll really get a handle on basic procedures. Finally, we're going to finish this section with ratios and proportions, which are just equations as well. So this will be a 2 or 3 segment video. The first thing that you need to recognize is that you must think about isolating the variable x. That is your goal when you solve an equation. You want to get this letter alone, and if there's something hanging out with it, like this -5, you got to get rid of it in order to get this x alone. Please notice that this question number 1 has 2 terms on the left-hand side, x minus 5, versus question number 3 has just 1 term on the left and 1 term on the right. I'm actually going to do, I'll probably go ahead and go with 1 through 4 in order. But what I'd like you to do is I'd like you to check for when there's more than 1 term on one side of an equal sign. And in order to get x alone, you have to do the opposite of what this reads. So this reads subtract 5. So what we have to do, and I like to do this vertically, we have to add 5 to both sides of this equation, because by doing that, on the left side, all we have left is an x, because this -5 and a +5 add to be 0. And on the right side of the equation, we just add 13 and 5 and get 18 for our solution for x. And if you go back and check this in the original equation, it was x take away 5 equals 13, and you put in your solution of 18, take away 5 is indeed 13. Now, I know some of you would say, I could see that. I could see that I need an 18 here for x, because when I take away 5, I get an answer of 13. It's true, but often as we get further and further into our algebra and trigonometry skills, we can't see the answer, so we have to know the procedure. So right here in question number 2, I've got 2 terms on the left-hand side, but here I have a +7. So to get rid of that +7 and get x by itself, I have to take away 7 from both sides, or add a -7 to both sides. Here I have just the x left, the 7's are gone, and I am just adding a -2 and a -7, and I'll get a -9. In questions 3 and 4, the procedure is, because there is just 1 term on each side of the equation, to isolate x, this reads, I'm going to write this out, it reads 5 times the letter x equals 30. So to isolate x, or make that x just become a 1x, what I'm going to do is divide both sides by 5 of this equation so that this will become a 1. I'm going to make it look like that. So that's a 1x, or just x. And on the right-hand side, 30 divided by 5 is 6, and I have my solution. Again, I could check that in my original problem, which reads 5 times whatever x is, x turned out to be 6, is equal to 30. And yes, it does work. 30 is equal to 30, so I know I got that problem correct. So again, this is a -6 times x. You know, we're dividing both sides by a -6, but it's like multiplying by a fraction 1 over a -6. But essentially, this principle here is called the multiplication principle. Again, multiplying by a -1/6, but this right here becomes just a 1. A -6 divided by a -6 is a +1x, and 42 divided by a -6 is a -7. Now look at this next one. It's x divided by 3 equals 8. And in order for this x to be all alone, what I need to do is I need to multiply it by, I'm going to write it as 3 over 1. because what you get there, and of course I'm going to come over here and multiply this by 3 over 1. Don't really need to be showing the 1, but I want you to see that this is 3x over 1 times 3 is 3. And so this 3 over 3 is equal to just 1x. And so finally we finish this problem. We get x equals 24. So again, if the value that's in front of the variable, if you will call it that, in this case it's 1/2. 1/2 is in front of the variable. When I divide both sides by 1/2, it's like multiplying by 2. So I'm just going to multiply this by 2 and that by 2 to cross those off, and I have y equals a -10. Again, this problem, it was y over 2 equals a -5, and I want to know if y is a -10, so I'll substitute that in, and I'll ask myself, is a -10 divided by 2 equal to a -5? It sure is. I put a check mark and say, good, you got it right. Finally, if I have not just dividing by a constant, if I have a full-edged fraction here, I'm going to write this out so you can see this a little bit better. I have a -3/5 times z equals 6. Then this -3/5, it's easiest to just say, let's multiply by a -5 over 3, the reciprocal. 3/5, 5/3. Don't change the sign, because a negative times a negative here will be a positive. And I'm going to do the same thing. I've got to multiply the right side by a -5 over 3. So I want you to know that that 6 that was over there, in order to keep it up high, think of it as 6 over 1, because that was just a number 6, and the number 6 is 6 over 1. So the right side of this problem is going to become a -30 divided by 3, which is a -10. That will be my solution for z. Z is equal to a -10. And that's because this right here, a -5/3 times a -3/5 is a positive 15 over 15, or in other words, again, 1z. So z here is equal to a -10. Again, I could check this. I'm going to go ahead and put that up here. So I have a -3/5 times z, which is a -10. I'm going to put that up high so I can see it, and know that when I multiply with fractions, that I multiply the numerators and then multiply the denominators. Negative times a negative is a positive 30. 5 times 1 is 5, and 30 divided by 5 is 6. Fine, let's do a couple more before we stop this particular segment. When I'm at that point now where I have to both, in order to isolate x, I have to add 5 to both sides, but then I have to divide by 2, I will always be doing my addition or subtraction first. So I will not do the dividing by 2 until I just have an x term on one side and a constant term on the other side. So first addition and subtraction, and then turn to dividing both sides by 2 to find out that x is equal to 9, and then finally come on over to the right and take your original equation, 2 times x, but x is 9, minus 5, and using order of operations, I'll multiply first and I'll get 18 minus 5, and then right there I could stop for my own sake. I'm doing this for myself. I want to see that the left side is equal to the right side when I put my solution into the equation. Finally, to get the 3x term alone, I've got this plus 20, so I've got to take away 20 from both sides. So I have a 3x all by itself on the left. Here I'm adding a positive 5 and a negative 20. That's what I'm doing right here. Those are different signs, so they combine to be they add to be a negative 15. And now I'm going to divide both sides by 3, and I get my solution. X equals a negative 5. I'm going to pause here. If you'd like, go ahead and start working a few problems on the next page, and then come back to my video and see how you've done.